Okay, so in this video, let's discuss how we can build a recommender system. And this was something that was given to me as a take-home assignment for for the data scientist role at a company. And this is the data set that was given. So we have columns like grade name, description, couple of others are there. Family product, product name, grade name, description, polymer types, filler, additives, features, then industry, sub-industry names, then processing techniques, and the region names where these sort of products are used, probably that's what it means. So this was the data set, and the task is to predict three most similar products given any of these products or any product outside these. So if let's say they give this as the input, this particular product as the input, now we want to recommend to the user three most similar products to this particular product. So this is basically some polymer sort of these are some polymer products, and these are the details about those products. Now, when it comes to the recommendation system, I used three approaches that I had in my mind. So I implemented two approaches, and then I will also tell you the feedback that I got from the interviewers on these approaches and how you can, for example, if you are building a recommendation system for your project or for any take-home assignment, how you can benefit from the feedback that I received from the interviewer. So it's going to be very helpful. I'll take you through the two to three different approaches that I used from the step of pre-processing or cleaning the data set to finally getting the three most similar products. So I'll take you through every single thing that I did for these three different approaches. And I'll also, towards the end, tell you the feedback and what could have been a better approach. That is something I'll also discuss. So I will share the, just a second. Okay, so this is approach two that I will come to for later, but this is the approach one for this question. So let me um, take you through this. So here I basic steps imported the data, and this is the data that we just looked at, different columns, different values for them. And this is basic pre-processing. I'm changing the column name, then replacing the TM trademark, basically symbol, by nothing. And because this is there in two of the columns here, so just replacing this. It's just a part of the pre-processing step for any NLP model or project that you will work with. So uh, basic steps here, data cleaning. I am just converting to lowercase to all the data. Then I looked at the description column and just tried to put down some points that what all things I can, I should sort of pre-process here. For example, maybe I want to convert C to Celsius and then maybe remove this complete, whatever is in the brackets. I might want to get rid of that, or just want to expand some terminologies that are there. For example, might want to remove this plus with and or something like that. Remove this percent symbol by the word percentage or percent. So just skim through this, and then you will get some idea that okay, what all things I might want to pre-process. So in the description column, as I said, I am expanding. There are some places where it's written deg C, so I want to expand it to degree Celsius. Similarly here, there is just C somewhere, so again want to expand degree Celsius. Then removing plus with space, And those basic pre-processing steps that I did here, again the same thing, converting to lowercase and then removing the brackets or anything inside the brackets. Uh, Moving on. Now here's the approach. So this was just the pre-processing part. Now let's discuss what is the approach one. Okay. So I used Doc2Vec to convert this sort of whole one record into a vector. So, okay, what do we eventually want, right? Let's say I'm working with the text, the data. Now, what's my end goal? As in, before I use any model to give me three similar products, my goal is to convert this text data into a vector, because that's what machine or the computer understands. It understands the data in textual form. So but I have the data in um it's I don't have a textual data, right? This is these are words or sentences. So first, my main goal is to convert these um words or sentences on in each column into text, or in other words into vectors. So there are a couple of ways to convert these this textual data into vectors. Now, one of the ways that I use in this first approach is I combine all the columns. So I take first record, for example, combine all the columns and put it, and make it a single column. And that becomes my document. Now, once I have the document, if I convert that document into a vector, that's all I need, because I can now feed the vector to the machine learning model, and it can again find those three similar vectors to the one that I gave it. So that's the thought process, right? I have this one record. I put all the values of this record, all the columns, into a single column, maybe by separating, separating by something like, here I'm using this bar operator. I don't know if this is called bar operator or something, but this is what I am separating every column by. So if you look at this, yeah, this is the first record. Okay, this is the first record. Now, what I am doing is, this is the value in the first column of the first record. Now I am separating this value using this pipe operator, and I am putting the value of the next column in the same record. So similarly, I append basically all the values in that row and separate them by this pipe operator. So this becomes my one document. This is basically representing my first record in the data set. Now, once I have this document, now it's easier to convert it into a vector. And once I have the vector, I can train a machine learning model on these vectors. Let's say I have 100 records or details of 100 products in my data set. So once I have these records converted into vectors, I give them to the machine learning model, and it will train on these vectors, and then it can eventually output similar products to me. So this is the thought process. This is the approach. Now, so I converted them. I basically put them together into a single column. For example, as you can see here, I separated them using this pipe operator. Now, why I separated these different values is because I wanted to keep the encoding of these different columns also sort of included in the vector, right? So I did not just mix the value of all the columns randomly, just put them together and then mix them. I did not want to do that. I wanted to also keep the essence of every column encoded in that vector. That's why I said, okay, keep this separate, and then separately maybe encode this particular value. And then by encoding these values separately for each column, you put all of them together and give me a vector for this particular document. So that's the reason I thought maybe I want to separate the values of each column. And now this can be so, and one of the feedbacks from the interviewer was that you could have not used maybe this operator or this symbol to separate the values of each column. Instead, you could have just put all the values together and then used that for encoding. So that could have been another approach. That's what the interviewer also said. I had that also in my mind, but I wanted to just keep the essence of each column also sort of embedded in the vector. So that's the reason I chose this. But you could again maybe just straight away put all the columns together for every record and then convert them into vector. Now, so once I have these documents, right, different documents for every record, now I want to convert them to vectors. Now, to convert these documents to vectors, there are multiple um, sort of what do I call different techniques to do them. One is, for example, Doc2Vec. That is what I use. It's based on word2vec. And again, you can also use word2vec where you convert um, every word into a vector using word2vec and then put all of them together. But it can have its own pros and cons. So I thought that Doc2vec will be better approach here. So I use Doc2Vec, but there are other approaches like universal sentence encoder is something that you might want to explore, and I'm sure BERT, etc., are other different um, sort of frameworks that could be used to convert them into a vector. But I use Doc2Vec. So now I have these documents ready. Now I want to convert them into vectors using Doc2Vec. So again, this is I think the pre-processing step here. Doc2Vec encoding, you install you need gensim for using Doc2Vec. So I installed the gensim, and then we want to now how would the how would you input every document to your model? How would you give it as an input, right? And how it would give you as an output? It can't, if it gives you, let's say you just input some random vector to it, you won't know for which document this vector is associated, right? So what Doc2Vec needs is labeling of every vector, or sorry, every document in your data set. So I have, let's say, 100 documents. Now, what it will do is it will label every document. So first document, let's say, labeled as 1, 2, 3, 4, and so on till 100. So and that's called basically tag the document. So we tag those documents, right, using these numbers. That you will understand a little better when we'll get to that part. But it requires every vector, or not every vector, but every document to be labeled or to be tagged. So that's how we can recognize those documents. So now let's say I want to get the output, or get the most similar vectors for a particular vector. So what I can do is I can give the tag, or the label of that document as the input to the model, and it will understand, okay, this is the vector that's coming as the input. And then it will give me three most similar documents labels. Again, it will give me the labels of the three similar documents, right? So let's see, you will understand that better once we get to that part. But this is just basically tagging those documents. Um, so, and here I'm training the model. Once I have the documents tagged, I want to take that, I want to train the model, right? The Doc2Vec model on this data set. So this is the code for training it. I am using vector sizes 40. Basically, for every document, it will output a vector of size 40. That's what it means. Min count and epochs is basically again running for 50 times to train the model. Min count, I'm not very sure. I'm not able to recall what it means because it's been a while I used this. And then it's building the vocabulary and training here, training the model on the examples, and it's taking the number of total examples from the corpus, and from here basically. Epochs, it's taking 50, and total example will be the number of documents that are present in the corpus. And here we go. So here, sorry. Now I am inferring once you have trained the model, now what this part is doing is it's giving out you the vector of the document that is labeled as 101. So this is how your document, which is 101 document, will be encoded. So this is the encoding, right? Infer vector basically gives you the encoding for this particular document that's labeled as 101. Now, what we want to do is we want to find the most similar vectors, uh, right, for any particular given vector. So I am giving it as the input 55th vector, and it's saying that 132, 59, and 30, these are the three most similar vectors to this particular document. Now, what is my 55th document look like? It looks like this. 20, this is the description of the 55th document. It says 20% mild glass filled enhanced flow uh, whatever internal mold release conforming, etc. And it says to this document, 132 is the most similar document. So let's look at what does 132 look like. It says 20% glass fiber filled super. So somewhere it is matching filled, and then thin wall application. So I don't think thin wall application or something like that is there. So this shows that it's not probably giving out very similar vectors. Maybe it's doing decent job. The model isn't performing very good. Now, at this point, we don't have any metric to use to see the performance of the model. It's just the visually whatever we can conclude, that's all we have right now. So visually, it looks like it's doing a decent job, not very good job, but okay job. Now it says again, 59th is the second most similar document to 55th document. Now, what does 59th document look like? This looks like transparent standard flow polythermide, eco conforming, etc., etc. Again, looks like not very similar to the 55th document, right? So maybe this is not giving very good results. Now, again, we can go back to this and then do some fine tuning of the model. I increased the vector size to 100, and then epochs to, I again played around with the epochs and then made it to 30. And there are a lot of other hyperparameters for Doc2Vec that you can try to play around with, tweak them, and see which hyperparameters give you the best result. But here I just played around a bit with maybe min count and epochs and then vector size. So now let's look at the result for this. Okay, my browser is not responding. Okay. So let's look at this. Made feature vector size 200, again training the model. And then if we want to look at this 101 document, what its vector look like. So its vector looks like this. This time we have 100 coordinates to represent one document, right? Now, if we look at this, we are looking for most similar vectors to 49. Now, what does 49th document look like? It looks like this. Ultim resin family heat solutions, blah, blah, blah. And then it says 14th is the most similar document to 49. I think I did not extract 14th. Maybe I would have, but I forgot to use it or to show it here. Then it says one node one is also one of the most similar documents. So let's look at one node one. It says height, heat, somewhere matching, because almost the numbers, like there's some number, then some words, so somewhere it is sort of matching. Then you can maybe read through it and see, how it looks. Do you think that these two documents are really similar when you just read through these? So what I personally felt is this is not performing very well. It's not giving the best result. So this was one of the approaches, but maybe I could have, as I said, instead of using this operator in the documents, I could have just put them together directly and could have used it. But this was one approach that I used. Now, the another approach that I took was this. So let me come here. And if we look at these columns, right? Doc2Vec, let's discuss what does Doc2Vec do and why I thought of the second approach. So Doc2Vec, what it does is basically it's built on the word2vec model. Now, what it does is it takes into account the context of the sentences, right, to encode them. Now, if we look at these columns, other than the description, they are not very coherent, right? If you, let's say, put these three columns together, um, there is no meaning as such in the sentence if you put them together. Or if you look at these other columns here, there is no coherence as such. If you put these together, it will be like heat stabilizer, unreinforced, no PFAS, intentionally added, high temperature resistance, high stiffness. So there is no sort of coherence, right? There is no meaning or in the context if we look at this. So what I thought that maybe instead of using this Doc2Vec that takes into account the context in the sentence to represent it into a vector, what I can do is I can only take those columns where the text is coherent, where the entries are coherent, and I encode other columns using something like tf-idf, which does not care about the context. So that's what my second approach looks like. Second approach, again, after the basic pre-processing that I did here, almost the same thing as we discussed in the previous in the approach one. So here what I did was I only took I think description. Where's the column? Okay, here. So I only took description column and the family name column for Doc2Vec encoding. Rest of the columns I encoded using tf-idf. Again, the reason being that here in the description, the text is coherent. It makes sense to take into account the context. For example, if I look at available, then if I look at the previous two words, powder is, and then with and, right? So it makes sense. The text is coherent. It makes sense if you read this powder is is available with an average. So this is a proper English sentence. And that's the reason I thought maybe I use Doc2Vec for columns like these where the text is sort of making sense if we read it. So that's the reason I chose tf-idf for the columns where it's not proper English sentence, and Doc2Vec for column like description and this family product. So that's what I did here. I am using tf-idf. This is the function that will convert the given column into the entries of the given column into a vector. So what I did, now let's understand how I am encoding these different these columns separately. So I take the first column, for example. I convert that column, let's say, using tf-idf. Now tf-idf gives me let's say a 30, the vector size is 30 for the first column that's converted into a vector. So I put this vector of size 30 into a single column in my data frame. I think that's very clear. The way it's here, for example, I have my family name. I take this value, okay, and let's say I'm converting this using TF-IDF. So this particular value will be converted or will be transformed into vector using vector size 30. So I will have now a vector of size 30. So I take that vector and put this here in a new data frame. So the column name will be this, let's say this only, and then the first entry is converted using a vector of size 30. So I put that vector here. This entry again size 30, I put that vector here. This again put that vector here. So again, now this family name is same for all the products. So we could have probably avoided this as well, but there can be cases where this family name is not the same for every single product. So we included it. So that's what I did now. I created another data frame, and for every single entry or every single cell, for example, in this Excel, I converted that into a vector and stored that vector into a single cell only. So that's the idea. Now I'm using this vector. This is my data frame where I am storing all these encoded documents. So in that, uh, I am in the same column name. I am I am keeping or I am adding the vector. So basically, I take the column, convert it into vector for all the entries in the column. I convert into vectors and keep those vectors into a single column. That's what I am doing here. So all these columns are the ones that I converted or transformed using TF-IDF. And then I used this Doc2Vec on product family name column and description column. These two columns I am encoding using Doc2Vec and rest using TF-IDF. So once again, the same process, tagging the documents and then uh, calling that function to tag the documents, initializing the model, training the model, inferring for, let's say this time, I want to infer for document one that what its vector would look like. So this document here, remember, is only the combination of product name and description, not the whole record, right? Um, so looking at this is how my first description and family name put together would look like in two vector form. Now, I thought that maybe because this description column is kind of a gist for every other column. So for example, if you look at this, it says, where did it go? Sorry. Here, for example, um, okay, for some reason it's not clicking. Anyway, what I'm trying to say is that the content of this description column is a gist of every other column. So from every other column in this data, there is some part coming into this description to make it as a column in itself. So I thought that this is probably a very good, sort of a summary of the whole record. That's why I thought, why don't we try to find the similar products using just description itself, not caring about all the other columns, just take the description and then try to see which are the other documents whose description match to this document. So that's what I tried here. I am saying that give me the vectors or give me the documents whose description is similar to the document 45. Now it says 129 is the most similar document. So let's look at 45th document first. Yeah, it says 20% glass fiber filled super high flow internal mold release, right? It says 129th is the most similar document. So I'm looking at 129. 50% glass fiber mineral filled high flow blend internal. More or less, it is close. Looks like it is close, right? There's some percent, and then the keywords are matching. Polyethermide, I guess that's how it's pronounced. Somewhere it's matching. It also says 73 is again the third most similar document. So look at 73. It says 20% glass fiber, high field flow. So what we can see is these documents are actually similar, right? In some sense, if you look at them, if you read through them, it says eco-conforming, then eco-conforming, then some number towards the end, listing some number again towards the end. So more or less, if you look at these, you could say that yes, they are similar. Somewhat they are similar. It means it is probably doing a better job than our first approach, right? Now, again, what I do is I increase the size of the vector to 100, train the model, and did I look at the similar documents again? Maybe yes. For 45th, it says, okay, I think I looked at some other documents similarity. But more or less, I think this is working fine. But now I looked here only on the basis of description. Now what I want to do is I have the column description. I have other columns as well. Now I want to put all of those columns together. I concatenate every single column for the record and then try to predict, right, the closest products. Now, how will we predict or find out the three most similar products after we concatenate every single column? We will use something like cosine similarity for that. So first, let's put the Doc2Vec encoding and tf-idf encoding together, because some of the columns we encoded using tf-idf, some of the columns using Doc2Vec. Now we want to combine them, right? So what the method that I use to combine them is concatenation. So I take every single column, the vector for every single column, and then just append those vectors one after the other. So now this gives me the representation for every single record. So if I look at the record number 1, I can concatenate every single value or the vector for every single column in record 1. After concatenating, it's a huge vector right now. And that is the representation of document 1 for me. Now, once I have that, then after that, it's easier to sort of find the similarity that we'll discuss. But now the first task is to put them all together, right? Concatenate them. So I use, sorry. What I'm doing is I am taking take the documents, concatenated column, and then I am putting this vector. Okay, let me just take a moment to understand what it is doing. Here what I'm doing is I made a new column named concatenated column in the data frame where I have the encoding for all the columns. So where there I add a new column, and that column's name is concatenated column. Now in that column, what I'm doing is for every row, I am adding the doc2vec encoding, right? Because once I have the doc2vec encoding, I can append the other encodings after the doc2vec encoding. So that's why I'm doing. I am adding all the sorry. I'm inferring basically the all the documents and adding them to the vector. Then here what I'm doing is I'm adding the tf-idf vectors together, putting them all together. So now I have obtained a matrix. For every row of that matrix represent the encoding for one document. And I have n number of those encodings because I have n number of documents in my data. So that matrix is, let's say, for encoding each document, I am using size of 400. So now every row has 400 values, and the number of rows are, let's say, 150, because I have 150 documents in my data set. So once I obtain that matrix, now I can use something like cosine similarity to find the most similar vectors on that. So here I'm using top three is my function which will give me the three most similar vectors. I'm using cosine similarity for that here. So once I have, you just look at the technicalities of this code, maybe using ChatGPT or internet. I will provide the codes as well in the description. So you can refer these notebooks and then take whatever you want, whatever you feel that will be helpful to you. Take them and maybe implement those for your project. So I'm just basically finding the cosine similarity using this function that will give me three most similar products for any given input. So this is the index is nothing but the tagging or the label of the document. So let's say I want to find top three similar products for 89th document. So it's saying standard flow equals something, then enhanced flow polythermide, then transparent standard flow, etc., etc. And these are 87, 115, and 102. These are the three most similar documents to 89. That's what it is saying. So again, they look somewhere similar. Maybe they have some keywords that are present in most of them. For example, this and when I tested this basically for a couple of other inputs. So here the input is 89. I tried it for other inputs as well, and there here maybe for this for example for this instance for this particular input, the output might not look very similar, but for others I tried, for most of them it was looking similar. For example, if you look at these three documents, they are almost similar: semiconductors, rail, electronic, blah 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 blah, automotive under the hood, automotive under the hood, automotive under the hood, semiconductors, rail, mostly similar. They look almost similar, right? So I think for this, this was the answer or the result for some document which I don't have here. Maybe I have deleted it or overridden it. But this gave very good result for most of the inputs. Um, Now I also tried uh, Euclidean metric to get the similarity between the documents. This is just an added bit that I wanted to show that I tried this also. Now let's say I give 34 as the input and I want to find the most similar to 34, then there are these. Uh, I think again you can see that most of them are somewhere similar, right? Reinforced polythermide, global food, resins, materials, mostly similar if you look at these. Then row compliant, intrinsically flame resistant without blah 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 blah. So if you read through these, they look more or less similar. So what I discovered is that this approach actually gave me better result than the previous approach. Now the results even improved once I dropped some of the columns. So I dropped grade name additives, filter it, additive percent. I dropped them because for some of them, maybe there were a lot of null values for, or it might not make a lot of sense to me to include them. So once I dropped these columns, some of those columns, it gave me even better results. That's what I realized. If you look at this, 144 enhanced flow temperature impact, high flow, polythermide blend, high temperature transparent, ductility, enhanced flow, 3 micron, something, something it is saying. But I felt this gave me better results ultimately. But now the problem with this approach is the following. Then that's what the interviewer told me, that I have the Doc2Vec vector, right? And that 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 vector representation in some vector space, once I append the other vectors to this Doc2Vec vector representation, it goes into some other vector space. Now, after you do that, it does not hold the same meaning, right? Because if, let's say, in the 40 dimension, it said that these two vectors are similar, okay, by certain amount. Now, once I append other columns to this, and from 40 dimension, I take it to 100 dimension, then the similarity might not hold. That is the problem, apparently, with this kind of approach, where we are appending the vectors, right? After converting each column into vector, we are putting them together by concatenating them. That is the problem with this approach, that the similarity might not hold into a higher dimension vector space. There was the problem. Now, what is the solution to this is the following, that what I can do instead is I convert each column. Okay, hear me out. I convert each column into a vector, right, by any method, whatever means we want. And then I find the similarity of every vector with every other vector in the same column. And then, for example, I converted this value into a vector. This might not make sense. Let's look at this, for example. I converted this value into a vector. Now, what I want to do is I want to find out the similarity of this vector or this document or this particular value with every other value in the column. So I want to find the similarity of this with this, with this, um, with this. So take first, find the similarity with every other column, every other value in the column, and take the three most similar values. Okay. Once you do that, you do the process with every single column. Now, after you have found, no, sorry, go back, little bit, going back. So you find the similarity of every value in the column with every other value in the column. Do the same process with every other column in the data set. So I did the same thing with this. I did the same thing with this, with this, with this, and every other column. And now take the average, maybe, of all the similarity scores. Once you take the average, for this particular document, you will have a single value of similarity with other documents. So for example, my average value says that this document is most similar to this particular document. This document is similar to this document. Now, this becomes your most similar document. Now, the second most closest value of similarity says that this document is the second most similar document to this first one. So that is probably a better approach. That's what the interviewer told me, that maybe convert each column into a vector, find the similarity of every vector in each column with every other value, right? For example, take this, find its similarity with all these other values. And then once you do that, do the process for every other column, take the average of similarity. For example, for this column, the similarity for this particular row, or for this value, the similarity of, let's say, similarity to this value is 0.5. Similarity of this to this is 0.3. Similarity of this to this is 0.7. Similarity of this to this. I mean, I'm taking the fourth record and the second record. So what I'm doing is I'm finding the similarity of second with fourth. how you will find, take the average of the similarities for this record, and that's how you will obtain the similarity of every other record, and that will be a better approach to follow. If something is not clear, let me know. I can maybe expand that a little bit in the comments or whatever. I'll provide the notebooks as well, so you can look at that. And this is where I would like to end the video. I hope I could give you some sense of how you can build a recommendation system for representing or for giving three most similar, products in this case. Thank you. Have a great time. Good luck.